Okay.
So 450 temperature, 200 atmospheres pressure, and nickel catalyst for Haber's process. The second one is contact
Okay.
process, also part of the physical chemistry. Contact process has these, again, three conditions. So a 450 temperature, 1 to 3 atm pressure, and
Okay.
vanadium pentoxide is catalyst. Contact process is used for the production of sulfuric acid. All right.
Okay.
Now for the organic chemistry. First of all, we have all these reactions for alkenes.
Okay.
Number one, it's the bromination or chlorination.
Right.
So the reaction conditions for bromination are room temperature pressure, RTP, standard room temperature pressure, and absence of UV light. Because this reaction, the addition reaction of adding bromine or chlorine is explosive in the presence of UV light. So absence of UV light is must for this reaction. And obviously you need to have either Br2 or Cl2 as a reactant for it.
Yeah.
Then the second reaction is hydrogenation. Hydrogenation is addition of hydrogen. Again, it's an addition reaction, electrophilic addition reaction for the alkenes. The reaction conditions for hydrogenation are 150 degrees Celsius temperature
Okay.
and platinum or nickel catalyst. You have a choice. Let's choose nickel because we chose nickel for Haber's process as well. So temperature could be either 150 or 200. This is an available range, 150 to 200 degrees Celsius nickel catalyst. Or you could also use palladium, platinum, any of these chemical elements. Okay.
Yeah.
Third addition reaction is hydration. Hydration is the addition of H2O, addition of water. And the conditions for this reaction are H3PO4 catalyst, phosphoric acid,
Okay.
and you need 300 degrees Celsius temperature and 60 atmospheric pressure. And then the last addition reaction is the addition of hydrogen halides. You don't necessarily need to remember any catalyst or any other condition, just need to have the appropriate reactant. For example, if you're adding chlorine to a halo or a, you could say an alkene, you need to have chlorine as a reactant. If you're adding bromine, iodine, you need to have bromine and iodine as reactants. All right. So there's no specific reaction condition for addition of
Okay.
hydrogen halides. All right, then yeah, there's another reaction that we study for alkenes, that is polymerization. I mean, not necessarily a part of alkenes, but because you polymerize for the addition polymerization specifically, alkenes are polymerized, so we need to know the conditions as well. Generally, yes, you need high
Okay.
pressure and high temperature. There's no specific condition,
Yeah.
but you just generally need a very high pressure or a high temperature for polymerization. So this is the fourth one.
Okay.
All right, and then there's this oxidation of alkenes, because you also, the two types of oxidations, the mild oxidation and the strong oxidation, you need specific reaction conditions for these two oxidation reactions as well. So let's take number 5th as
Okay.
mild oxidation of alkenes. So for this mild oxidation, you need cold, dilute, and alkaline conditions.
Okay.
And the oxidizing agent is KMnO4. Similarly, for the strong oxidation, the conditions are hot, concentrated, and acidic.
Okay.
And again, KMnO4 is the oxidizing agent.
Yeah.
To see how you're also somehow revising the topic side by side, all the reactions for alkenes, the conditions, and you just
Yeah.
have to know the products
Yeah.
now. So after the I think that is it from alkenes. Is there anything left? I don't think so. Yeah, we're done.
Okay.
So let's move on to halogen alkenes.
Okay.
The first reaction for the halogen alkenes is the nucleophilic substitution reactions. And for
Okay.
each of the different mechanisms, let's see. Okay, so I'm going to categorize these nucleophilic substitution reactions into 3 different segments according to the substances being used for the substitution. So number 1 is the SN. I'm denoting these nucleophilic substitution reactions with the symbol SN. SN with
Okay.
OH. So when OH ion will displace a halogen from the halogenoalkane, in that case, you will need a sodium hydroxide aqueous and reflux. So this OH ion basically comes from the sodium hydroxide.
Okay.
Similarly, the nucleophilic substitution with CN negative ion, cyanide ion. So the cyanide ion, you'll need the sodium cyanide, NaCN, ethanolic. The solvent used here is the ethanol and ethanolic, yeah. And again, you need reflux for this.
Okay.
Third reaction is SN, again, nucleophilic substitution with
Right.
NH3. NH, yeah,
Yeah.
NH2, sorry, because NH2 will displace the halogen here. So for NH2, you'd need NH3 ammonia here, gas. In a sealed tube, so there are 2 conditions. We have these choices here. Number 1, you can either have NH3 gas in a sealed tube plus heat, or you can have NH3 ethanolic with reflux.
Okay.
All right. And yeah, so after the nucleophilic substitution reactions, there is an elimination reaction for the halogenoalkenes. Number 4.
Right.
For this elimination, you will need NaOH ethanolic with reflux. All right. I think, yeah, and the last reaction. It's not a reaction, but it's just a test for the identification of halides. The hydrolysis test, where you use AgNO3 and NH3, and you see the colors of chlorine, bromine, and iodine ions. It's just for the
Okay.
identification of the halogens. So let's just write it here, hydrolysis for identification. It's not a reaction, it is a test. So you
Okay.
need AgNO3 aqueous plus, sorry, and then the NH3 for the identifications. And I think we're done with halogen alkanes as well. Now the alcohols.
Okay.
You want some time to maybe write these down?
Oh yeah. Yeah.
Okay. Alcohols now. The first reaction for alcohols is the fermentation reaction.
Okay.
We've already covered the hydration of alkenes because you can get an alcohol through hydration as well, and that's a part of the electrophilic addition. So we're going to start off with the fermentation here. For fermentation, you need yeast catalyst, a temperature of 20 to 40 degrees Celsius, and absence of air. Air should be absent because it can oxidize ethanol to ethanoic acid. Because you see, in fermentation, you use yeast to produce, sorry, you use glucose to produce ethanol and carbon dioxide. So
Okay.
this is what fermentation is: glucose to ethanol to CO2. If you want to write a chemical equation, it's C6H12O6 to 2C2H5OH plus 2CO2. This is a fermentation reaction. Now this ethanol can react with oxygen to produce ethanoic acid. So this is why you
Okay.
need to avoid oxygen here, presence of air, right?
Yeah. Yeah.
And there's another way to obtain an alcohol, that's by distillation. You can distillate different chemical substances and you can obtain ethanol at 78 degrees Celsius, the boiling point.
Okay.
All right, the second reaction is the oxidation of alcohols. Oxidation of, yeah, because the reaction conditions are same for primary and secondary, so we're going to just write oxidation of alcohols.
Okay.
For both primary and secondary, for the reaction conditions are K2Cr2O7, that is the oxidizing agent. It turns from orange to green. You cannot use KMNO4 here because it is a very strong oxidizing agent. It's not preferred here. Similarly, yeah, that's it. And then we can also use reflux, yeah, for secondary alcohols specifically. And obviously there's no oxidation for the tertiary alcohols. The third reaction is the reduction of a carboxylic acid back to an aldehyde and then back into an alcohol. You see how when you oxidize a primary alcohol, you get an aldehyde and you get a carboxylic acid. And when you oxidize a secondary alcohol, you get a ketone.
Yeah. Yeah.
So reduction is when you move backwards. When you reduce a carboxylic acid, you get a primary alcohol. And when you reduce a ketone, you get a secondary alcohol. So reduction of both the carboxylic acids and ketones. The reaction conditions are same for both. You need to have a reducing agent first of all, that is LiAlH4, and the solvent must be dry ether. Or you can also use NaBH4. For this, the solvent must be ethanol.
Okay.
All right. This was reduction, and then the last one for alcohols is dehydration.
Okay.
For dehydration, you use concentrated H2SO4 or Al2O3 or SiO2
Okay.
plus heat. The problem with H2SO4 is that it is also an oxidizing agent, and it can oxidize the alcohols to carboxylic acids. So this is a problem. It's not preferred.
Okay.
It's better to go with either Al2O3 or SiO2. Now
Okay.
we are done with alcohols as well. The carbonyl compounds now. Aldehydes or ketones. The first is the identification test. Identification
Okay.
of a carbonyl compound in general. There could be an aldehyde present, or there could be a ketone. So you need to first of all identify the carbonyl compound, and for that you use a 2,4-dinitrophenyl hydrazine compound.
Okay. Oh wait.
Yeah.
I don't. What was the definition of that one? The old. I mean the. Oh, wait. Never mind. Never mind. Never mind. So we're just going through.
Mhm.
Are we just going through the nomenclature? Are we just like going through the identifying like what
Mhm. We're identifying
what
the carbonyl
compounds
compounds.
are in? Okay.
So basically, carbonyl compounds are either aldehydes or
Okay.
ketones. So if you want
Right.
to, let's say, identify if a substance has either an aldehyde or a ketone, you're going to use 2,4-DNPH. Once you add this 2,4-DNPH to that substance, you'll observe a color change from, I think the color, yeah, it was orange. So whenever a compound turns orange in the presence of 2,4-DNPH, you will know that that compound either has an aldehyde or a ketone.
Okay.
Once you know that carbonyl compounds are present, you then further oxidize them to distinguish between the two. Okay. So
Okay.
this first test is identification for carbonyl compounds in general. And the second one is the oxidation of aldehydes, because ketones, they don't get oxidized. Only the aldehydes are
Okay.
oxidized. So if, let's say, you get a positive test with oxidation of aldehydes, I mean, you're going to have a confirmed presence of aldehyde in that substance. Yeah. Because ketones, they don't get
Okay.
oxidized. So for oxidation, you can either use K2Cr2O7. For this, you're going to observe a color change from orange to green. Sorry, I forgot to write the color change for this one as well. You're going to see an orange color.
Okay.
Orange color upon positive test. And okay, you could either use K2Cr2O7, either you could use a Tollens reagent. Tollens reagent is basically a silver solution containing silver ions, and you could observe a color change. You could maybe observe a silver mirror, a layer of silver, or a black precipitate. And the last one is a Fellings reagent having copper ions.
Okay.
For this, you can observe a red precipitate. So whenever you get these following color changes within any of these three oxidizing agents, you'll know that there's an aldehyde. All right, because aldehydes are the only carbonyl compounds that undergo oxidation. And the third type of reaction for carbonyl compounds is the nucleophilic substitution of CN negative.
Okay.
So you use a ketone and substitute CN in place of the double bond O of the ketone. And for that, you need to have HCN reactant, hydrogen cyanide, and NaCN catalyst.
Okay.
So we're done with this as well. And the last bit is the carboxylic acids. I'm going to give you time to copy these down at the end again. Carboxylic acids undergo this esterification reaction. It's also for the alcohols. So number one, the esterification, that is the reaction between alcohols and carboxylic acids. It's also known as the condensation reaction. So you need H2SO4 sulfuric acid and reflux for this esterification condensation reaction.
Okay.
And the backward reaction is hydrolysis. Simple.
Okay. All right.
I think we're done. Yeah. Okay. So these are all the reaction conditions. I think yes, these are all, yeah. Because the last topic is organic analysis and there is no reaction in that. So the purpose of making you write all of these was to somehow have a recap of the entire organic chemistry and the reactions that the reaction mechanisms that we've studied, and you should know the reaction conditions. Most of the reaction conditions are pretty similar to one another. You should know the names of the common oxidizing agents, the common reducing agents, the method of reflux, what reflux is used for, when you need specific heat conditions, and then whenever you need specific high pressure conditions. So once you study the reactions in detail, you'll spot out a lot of the similarities between the reaction conditions of all of these reactions. You can take some time to write these down.